Good afternoon, everyone. Thanks for joining us again. This is part two of our Hunter Southeast two-wire webinar series. We're glad that you're able to join us. My name is Reid Garner. I am the Southeast Specification Sales Manager. I cover basically from DC down to the New Orleans area, everything in between except peninsular Florida. Got my counterpart here, Dirk Hessman. He is our Field Service Manager for the Southeast. So he's our technical guru that fixes all the problems. Not that we have a lot of problems, but Dirk's the guy that we go to when we need something fixed. So what we're going to talk about today is we're going to continue where we left off last time. So if you weren't able to join us last time, we covered a basic overview of two-wire science, kind of how it works, how it's different from a conventional system. So I urge you, if you did miss it, you can go online, and this video is on our go-to site. So you'll get a follow-up email for this from this webinar with a link to this recording and a reply email back to me. So if you didn't see the first one, reply back to me and say, hey, send me the link for the first one. I'd like to see it, and I'll certainly send that to you. So I'd encourage you to go review that because there's some good information there. We covered some electrical concepts that are going to be very important when we move into sort of the troubleshooting later in this one, and really in part three next week is when you're going to really need to know those electrical concepts. So like I said, go check that out if you haven't done so. But today we're going to kind of talk about, okay, you've got the concept of how two-wire works, what it does, when you should use it. So now we got to think about, how do we lay out a system? If you're a landscape architect or an irrigation consultant or a design build contractor and you're designing a system, what are some of the things you need to be thinking about when you're designing a system? From then we'll move on to what are some best installation practices. We'll talk about sort of some of the tricks of the trade to make life easier for you, some of the things you need to pay attention that will make your life easier down the road, and so you don't create problems and have to go into that troubleshooting part of it. And then we're going to talk today is going to be real basic troubleshooting. Dirk's going to come in and he's going to talk about the troubleshooting portion. Today we'll really focus on the diagnostics that you can do from the controller. Next week is when we're really going to get into sort of the field troubleshooting, going out, tracing the wire, using an clamp ammeter, those sort of things to figure out where you've got faults and certain things like that. So it's kind of how this is going to line up. I will say that the link that we originally emailed out 6 weeks ago for part three, it was a bad link. We've since updated it on our Facebook page and we've sent out updates, but if you happen to go to try to register for part three and it gives you a kickback and says this webinar has already, I think it says like already been in the past or something like that, but email me, or at the end of this, I've got the link to it, and I also will put the link to it in the follow-up email to this webinar so you can register right there. So please join us again next week. So without further ado, let's get started. Dirk, you got anything before I get going?
No, I think you about covered it. Like you said, I cover Virginia, kind of like a swath all the way down Virginia, South Carolina, North Carolina, Georgia, Tennessee, Alabama, Mississippi. So hopefully I've either met you guys or will meet you sometime. Yes and no, but on good terms. So let's crank it up and see what we can do for you.
Sounds good. All right. So we'll start off talking about some design considerations when you're laying out a system. So when we talk about an output or a run of wire from the controller, the term that we use is called a path, a two-wire path. So from here on out, you're going to hear me say that term. That's what I mean. So you've got one pair of two wires leaving the clock going out to the field. That is what we call a path. The ACC2, which is this guy behind me here, the one on the slide is actually our original ACC1. The ACC2 has 9 available paths from the controller if you use all the expansion modules. With the base package, it has 3, but you can expand that up to 9. So you have 9 available, what we call two-wire paths from the controller. Now, it's important to realize that the decoder stations can be on any of the paths, all of the paths in any combination. All of your decoders can be on a single 2-wire path. If you've got 100 decoders, 50 of them can be on one, 50 of them can be on another. Just kind of depends on how the system lays out. So what you really need to consider is, how do I reach all of my valves most efficiently? And then we'll talk a little bit more about this in a second, but how do I also isolate this system into sections so I can ease troubleshooting in the future? So another important thing to realize is you don't need to loop paths together. So when you get to the end of the path, it's the last decoder, that's where the 2-wire path terminates. No need to loop it back around to another path or cross it, anything like that. You just need to just end it right at the end of the last decoder. When you're planning your wire paths, just like when you're running a conventional system, you're gonna place a decoder on the 2-wire path where each valve is. And these, like we talked about last week, just uses a regular 24-volt AC solenoid, so you don't have to order any special solenoids. Works with a regular 24-volt solenoid that you get from stock. The max distance from the controller to the furthest decoder on each path for the ACC2 depends on the wire gauge. If you use 14 gauge wire, you can go 10,000 feet. Use 12 gauge wire, you can go 15,000 feet. So that distance is from the clock to the furthest decoder. Now, when we talk about going from the decoder to the solenoid, the max distance that we recommend is 150 feet. Now, I don't really ever see many situations where you're gonna have to go farther than inside a valve box, because typically you're gonna have the 2-wire path coming into the valve box. I've got a nice picture of this coming up in a few slides. You're gonna have your decoder spliced in right there, right to the valve. So there's really no need to be going, extraordinary distances from decoder to solenoid, because it really complicates things. And if you don't know where the solenoid is, if it's buried, it's going to be hard to trace. So 150 feet is the maximum, but that's really reserved for special situations when you need to do it. So just keep that in mind. So here's where we talk about the different multiple wire paths. So if you look at this chart here, you've got a different color for each 2-wire path. So you've got on the left side there, you've got a purple 2-wire path. In the middle, you've got a blue, and over to the right, you've got an orange. So the nice thing about this is you can sort of break your system up into different sections. This will definitely make life easier when the system gets older and you have to service it, because you can isolate different parts of the system. If you've got a problem on, let's say you've got 200 valves all on the same 2-wire path. Well, if you've got a problem somewhere in there, you really don't know where it is. There's no way to isolate it. But if you've got it split up into 75 a piece or something like that, you can sort of isolate each section of the system. So when you're designing this out, when you do multiple 2-wire paths, you want to use a different colored external jacket. We'll talk about the wire in a minute. It's available with a different colors of the outer jacket. And the reason for that is so if somebody's digging out in the field 500 feet from the controller and they get down to the 2-wire path and there's 3 2-wire paths running, if they're color coded, they're going to know which one is which in the field without having to break it open or anything like that. Another important concept is to always bring if you have multiple paths, always bring them all the way back into the clock. I've seen it way too many times where, and this is common, especially with conventional systems, you'll have your wire paths converge maybe 20, 50 feet from the controller, and somebody will splice them in a splice box in the ground and then run a single path up to the clock. Just go ahead and take all those paths all the way back up to the clock. Because like I talked about, when you're simplifying troubleshooting, you can remove one wire path out of the clock, remove another wire path out of the clock. That's in a splice box there. Guess what you're going to have to do? You're going to have to break those splices up and then test at that point. So bring all your wire paths all the way back to the clock. You're running these wire paths, you want to run them in the pipe trenches for your main or your lateral lines where possible. Number one, this is just an efficiency thing, so you can use, you're utilizing the same trench. Number two, you're going to put the wire on the bottom of the pipe, so that's going to sort of protect that wire path. Then number three, it's just a logical way to route the wire. And if somebody doesn't know the system and there's no as-built and they don't have a wire tracker, they're going to see where the valves are laid out and say, okay, I kind of understand that this is the direction that the wire is running. You can splice a 2-wire path anywhere. 3-way splices like we've got here in the purple and then here in the blue, those are permissible. But a big disclaimer when it comes to splicing is always, always, always put splices, any splice in a valve box where it is accessible. Dirk can probably back me up on this, but probably 90% of all issues that we see with 2-wire systems happen at a splice. It's a bad splice. Is that pretty, Dirk, is that fair assessment?
Yeah, plus also it helps in isolating. Like if you're looking for a problem, you can look for it. And also when we get into how to use a clamp meter, you can, start at the controller, work your way out. And if you got something where you could get to one leg or the other, it just makes it easier without having to really hunt and search for specific items.
Yep. So it's a good thing. Always never bury a splice. I'll tell on myself a little bit here. So I have a 2-wire system here at my house. I have 7 zones, so it's nothing extraordinary. I just wanted to learn how it worked. And I was splicing a wire path and I ended up breaking it. And so I spliced it back together and I thought, you know what? I'm not going to worry about putting this in a box. I'm just going to bury it. Nothing's ever going to happen with it. Well, I guarantee you about a year later, the valves that were downstream of where I broke that wire and I buried that splice stopped working. So guess what? It came back to bite me. So that's just a true story that you don't ever need to bury a splice. You always want to have those accessible. Moving on, we talked about the max wire distance. So that applies to the distance between the controller and the last decoder on the path. So if you follow me here on this blue path, so that would be, let's say we're using 14 gauge, you got 10,000 feet to work with. That would be 10,000 feet from here to here max, from here to here max, and from here to here max. So it's the furthest decoder away. That's your max distance. So like we talked about, 10,000 feet with 14 gauge, 15,000 feet with 12 gauge. We talked about this last time, and it's just another illustration of why 2-wire is such a valuable tool to use when you have a phased project. So you only need to put decoders and valves where they're needed. So it is possible to have the controller at, let's say, the entrance of an HOA project. For whatever reason, they're going to start building in the back of that neighborhood. You can run a 2-wire path all the way to the back, have all your active valves at this moment in the very back. And then as it builds out, you move backwards and you just splice decoders in along the 2-wire path, just like this. So this is a very important advantage that you need to remember when you're asking yourself that question. Do I need to go 2-wire? Do I need to go conventional? So great flexibility. That's what we're looking for with 2-wire. And like I said, if the plans ever change, if you need to add a valve somewhere, it's just as simple as splicing into the 2-wire path. Just make sure you put that splice in a valve box. We talked about the wire. So here's what this stuff looks like. I can't stress enough how key specifying, designing the proper wire is to a successful design and install. Color coding, like we talked about, it's easy to separate the 2-wire paths for troubleshooting. So you can see it's got that outer protective jacket that's available in a wide variety of colors. You can get this, specify this from Hunter. We have part numbers for it. And there are also other wire manufacturers out there that manufacture the same thing. You just need to make sure that it meets Hunter specifications. Conduit's not required by Hunter, It's only really required if you're working within a municipality where it is required, which is pretty rare. But I will say, if the project budget allows for it, it is a good thing to have. I've seen projects where the 2-wire path was put in conduit and then something happened where they built a road or somehow it got broken, and they had all these issues on the 2-wire path. Well, since they had conduit there, they were able to replace the entire 2-wire path between each valve by just pulling out the old and pulling in the new at the same time. So gives you some flexibility, protects the wire, but it's not really required. And it is a lot of times it ends up, if it does get installed, it gets value engineered out. But if the project has the budget for it, I would definitely recommend it, but by no means is it required. We call this our wire, our part numbers call it ID wire. And you can see on the inside of it that the wires on the inside are red and blue. So that matches up to the decoders. The decoder leads are red and blue. So it's very important that you keep those two. So when you're splicing in a decoder to the 2-wire path, you go red to red, blue to blue, because they do have a polarity, and you got to make sure that you keep that. If you end up crossing the 2-wire path, you get an overload. So just pay special attention to that. But this is direct burial rated. It's color jacketed. The jacketing provides protection, and it does provide that color ID. And the reason that we specify what we call twisted wire, and I wish I had an example of it here, but it's basically inside the jacket, it's twisted a lot like this. And what we've found over the years, we've been selling decoder systems for 20 plus, almost 30 years now, that twist does several things. It reduces surges. So if you think about it, if a lightning surge gets into that, there's more, it's got to move, and it for whatever reason it can tend to spin that out. It's stronger. That twist makes it stronger, so it's more resistant to, if it gets pulled, it's not going to break. And then the twisting also cuts down on outside electrical noise that can come in from, any sort of other electrical motor, like an AC unit or a pump, something like that. It resists that outside electrical talk a little bit better than 2 wires side by side. So that's why we specified this particular type of wire. So like I said, I highly encourage you, and we require you to use this type of wire. The other thing is, I get a lot of questions, if it's a conversion, do we want to use the pre-existing wire? If you're going from a conventional system over to a 2-wire system and you've got existing wire in the ground, do we want to convert that over? The answer is, if it's an ACC2 system and an ICD, absolutely not. It's just, we don't know what's in the ground. We don't know the integrity of that wire, so I would really highly discourage that. Now, with the easy decoder system, there's a little asterisk here. With the easy decoder system that we talked about last week, that's sort of the conventional, it's a conventional system in a 2-wire body, that it can be okay in certain situations. So if anybody on the line here has a job like that currently, get with me or Dirk and we'll kind of talk through it. But we're talking in terms of ACC2 and ICD decoders. Really don't want you using existing wire. It needs to be the new ID twisted jacketed pair. All right, wire connectors. I just preached to you a few slides ago about how critical these are and how critical it is to make a good splice. So splices in the 2-wire path, so between decoder and 2-wire path, and then if there's a T-splice, must be made with what we call a DBRY6, and that is a splice kit that is rated to 600 volts, and they have a high temperature resistance. We actually supply one splice kit with every decoder. So when you buy the ICD 100, you get a splice kit with two DBRY6s in it for you to use for that splice. So the reason that that's so important is, remember we talked about in part 1 that we're not just sending voltage down this 2-wire path, we're sending communication. Not only is that the case, but we talked that the wire path is always hot, so it's always constantly pulsing. So the reason that we require 600 volt connectors, even though this is like a 30 to 35 volt signal, is because that constant pulse up and down and the fact that we're sending communication, we have to have that 600 volt rating for it to last long, because if it's constantly pulsing and hot, it will, in a regular run-of-the-mill wire splice, it will degrade that over time. I've seen taking apart wire splices that were just burned black that weren't this DBRY6. So really highly encourage you to use that. The other thing is, I want to show this. I love this little piece. My buddy at Page Electric gave this to me. So this is, I don't know if you can see this. So right here on this side is just a regular old wire nut. Over here is the wire nut that we supply with this DBRY6. I don't know how well you can see that, but do you see how much better grip and how much better copper to copper connection you get with the one that we supply? So just remember, we're sending communication, we're sending information across that. So we want the highest integrity of a splice that we can get, and these splice kits are what get it. So always specify DBRY6 with on your 2-wire path. Now the decoder to valve connectors, so on the other side of the decoder, these 2 black leads that go to the solenoid, it's okay to use a regular, what we call a DBY waterproof connector on that side, because that signal is a little bit different. It's not that constantly hot pulsing signal. Here's an example. So on the right side, you've got the ones that we package, the DBRY 600s. And then on the left are your average run-of-the-mill 30 volt max. Those are the ones that are okay for your decoder to solenoid. 2-wire path splices absolutely need to be the DBRY 600s. It's a great picture of what a nice, perfect installation looks like. So you've got your main line coming through, you got your valve teeing off, then you have both of your splices. So you got your splice on the 2-wire path made with the DBRY6s right here. Then you've got your decoder over here. I got a better picture of this in a minute, but a good practice, don't see it a whole lot, but I like to see using, this is a Schedule 80 nipple that's basically driven down into the ground as a stake. And then you've got a 3/4 inch piece of PVC behind it, and the decoder is attached to that piece of PVC. So it's basically like a little decoder holder almost, which it makes life a lot easier when you're troubleshooting. So you've got the 2-wire path coming in. So this is a nice, pretty clean installation of a decoder in a valve box. We do recommend always giving us some slack on the wire path, 5 feet, 3 to 5 feet, really get closer to 5 feet. So you designers out there, that might be something to put in your installation notes, that at all splices need 3 to 5 feet of extra wire splice. Does 2 things. When Dirk's out there trying to fix a problem, he's not having to stick his head down in the valve box to figure out what's going on. He can actually pull it out, stand up, take some pressure off of his back. Then number 2, if the splice ever has to be redone and you have to cut a little bit out of the wire path, you've still got plenty there to work with. So always cut some slack. Secondly, can't reiterate enough, don't bury a splice. And then here's a better picture, a live picture of that setup I talked about with the electrical ties, 3/4 inch piece of PVC, and then a 1/2 inch Schedule 80 nipple. Works really well. So if you're designing a system out, one thing I recommend is doing that. Now let's talk about grounding. So grounding is very important with a 2-wire system. So I want to dispel a myth really quick that 2-wire systems get a bad rap, that they attract lightning. You know, any irrigation system with copper in the ground, whether it's 2-wire or conventional, is going to attract lightning. The reason that we are so concerned with grounding on a 2-wire system is because what you're doing is, it's your insurance policy. Would the system work if you don't ever ground it? If you put no grounding, yeah, it's going to work. I'm telling myself again, here at my house, I don't have any grounding, but you're protecting your decoder investments. Decoders cost money. I mean, you know, list price of a ICD 100 is close to $200. You need to protect this investment. So you want to always ground the controller per what the controller is specified for. So just check the ACC2 installation guide for that. but our minimum requirements, let me make sure I get all the pictures here. Our minimum requirements are every 12th decoder or every 1,000 feet, whichever comes first. That's the minimum. Now, I'm here in Atlanta. We get thunderstorms pretty much every day in the summertime. So I would consider us a high lightning area. Florida is really high lightning because they get thunderstorms 9 months out of the year. So in those cases, or if you know the property that you're working on for whatever reason, it attracts lightning. Maybe it's at the top of a hill or something. It's been struck by lightning several times. You might want to ground a little bit more frequently than every 12 or every 1,000 feet. You might want to go every 6 decoders, or you might want to go every 500 feet. Moving down the path, you always want to ground the last decoder on the path. And what we're doing here with grounding is we're making the resistance on the 2-wire path 10 ohms or less. Now, this can be tested with what we call a megger. And sometimes I've seen some of my irrigation consultant customers, if they specify a job, they'll go out with a megger and test to make sure that that grounding line is ohming out at 10 ohms or less. So that's what we're trying to do. So we're trying to decrease the resistance as much as possible. So when a lightning strike gets into the 2-wire path, it's going to move out as quickly as possible without causing any damage. So that's why we want that resistance. Remember, we talked about resistance in the last session. We want to make it easy for that lightning to get out. So how do we do that? What are the specifics of doing that? Like I said, every 12 or every 1,000 feet, you want to ground the end of each wire path. So like the example we just looked at before, if you've got multiple wire paths, at the end of every path, the last decoder you want to ground. And then you also want to ground every 12 decoders or every 1,000 feet. Most newer jobs are going to be using what we call a ground plate, and I'll show that in a second. Still see a lot of people using ground rods, but here in Georgia, we've got red clay, and I used to think I was a strong guy and lifted weights, and I think I can count on one hand the times I was able to drive an entire 8-foot ground stake into the ground without it bending over sideways just because the ground was so hard. So a lot of guys now have moved away from the ground rod, use a ground plate. I prefer the ground plate. But the important thing to realize is whichever way you go, got a better slide that shows this in a minute, you want to go 8 to 10 feet away from the wire path and at a right angle to the wire path. The other thing is when your grounding points, so a Hunter ICD decoder has this built-in ground lead. It has built-in surge suppression. Some other manufacturers of 2-wire products out there, you have to buy a specific surge suppression module that has 2-wire in, 2-wire out, and then the ground out. So the nice thing about our ICD decoders is they have this ground lead that's built into the decoder. So we don't need any additional surge suppression devices. So here's what that looks like. So you've got the decoder spliced into the 2-wire path. You've got your 2 black leads going over to the solenoid, and then right here you've got that bare ground wire. This shows a DBY here, but we really recommend what I call them acorn connectors, but they basically allow the 2 ground wires to sit like this, because what are we doing? We're cutting down on resistance. If you were to splice it and twist it, that creates resistance. We want the least amount of resistance possible. So we use 2 little acorn clamps, clamp the ground wire like this, move that out at a right angle to the wire path, just like this, at least 8 feet away. And then you're going to place the ground plate there. Got a picture of that here. So the way a ground plate works is, like I said, 8 feet away, perpendicular to the wire path, 90-degree angle. You want to go 36 inches deep, 6 inches wide. So the ground plate is typically 4 inches wide, so it's about like that, and it's 36 inches long. So not only are we going to bury this, but we're going to wrap it in what we call a power set earth contact material. So you get this at any irrigation distributor. It's I forget the material that it's made out of, but it's it assists in getting that electrical charge from the ground plate out into the ground. So no matter what type of soil you got, if it's not a conductive soil or a conductive soil, that power set's going to assist in moving that lightning charge out and dispersing it out into the ground. So this is what a detail of a ground plate in the ground looks like. Here's an actual picture of that. So on the left-hand side, you've got the ground plate. On the right-hand side, here's a ground rod. This just shows a couple of older ways to connect it. The one over there on the right is called a CAD weld. They have basically what we call, it's like got almost like explosive gunpowder in it. You light the charge off and it kind of almost welds the ground plate to the ground lead together. Don't do that before you go get on an airplane, because they're going to do that to your hands and you're probably going to get thrown in jail. So just FYI there. But like I said, typically don't see ground rods, still kind of common, but a lot of guys are moving to the ground plate. You designers that are on the call, I would definitely probably encourage you to do the ground plate, because just easier to install. It's going to be put in properly, and the installers are going to love you for it. Do want to talk about decoder types before I turn this over to Dirk here. We have several different kinds of decoders. We have a single station decoder, and basically what that means, we talked a little bit about this on the last call, but this has one connection to the 2-wire path and then one set of leads out to control one solenoid. We also have multi-station decoders. We have a 2-station, a 4-station, and a 6-station decoder. We have sensor decoders, and those are used, I've got a sensor decoder right here. So these are used if you want to put a flow sensor or a click sensor, like a rain sensor, an on-off type sensor over the 2-wire path. You can do that with a sensor decoder. You've got your leads for your 2-wire path in, and then you've actually got two leads for 2 different sensors. You want to pay attention to the positive and negative leads on these. So on your sensor, you typically will have a black and a red lead. So you want to wire your red to the positive, your black to the negative. We talked about that ICDs include that integrated surge suppression, so you don't have to buy an extra piece when little surge suppression module when you're grounding. Multi-station decoders. Now I could start a bar fight based off of, do I use multi-station decoders or not? There's certain guys that say I will never use a multi-station decoder, certain guys that use them all the time. Somewhere in the middle, the non-biased information that I can give you is that you would use them at a manifold when you've got several valves right next to each other. And the advantages are you're going to save money on decoders. So instead of buying 4 or 6 decoders, you're going to buy 1. And you're going to reduce the number of splices into your 2-wire path. The disadvantages are if, for whatever reason, the decoder gets hit by lightning or it cracks and gets water in it and it stops working, instead of just one station going down, you've got all your stations going down. So the guys that say they stay away from multi-station decoders, that's typically their reasons. They say, I don't want to put all my eggs in one basket. I want to separate all my decoders. The guys that do like multi-station decoders, they do them because less wire splices, so that's less availability for air there in a splice, and then obviously you're going to save a little bit of money. So really kind of depends on the situation and your personal preference, but just wanted to lay the information out there for you. So I'm going to turn this over to Dirk. Dirk is going to talk about programming the decoders. We talked about with Hunter decoders that they're programmed with the station number. You don't have to enter a serial number or anything like that into the clock. You can program it from the programming port or from our ICD-HP. So I'm going to let Mr. Dirk here take over and talk about programming decoders.
All right. All right, so we are going to start here. Hopefully you are going to be able to see this.
Yeah, looks good.
All right, if that's where we need to be, we're good to go. This is a screenshot from our ACC2 controller, and you can see you have a drag down menu when you go to the decoders. When you go to the first one, it's program a decoder. You can stick it in the port. You can program it 2 different ways, at the controller or out in the field, using the ICD-HP, like Reid had said. To program it at the controller, you stick it in the port, red and blue, and then you'll actually find the decoder. It'll tell you what type it is, and then it'll pull down the screen that's down below. From there, you have, like, if it's a 2-station decoder like it is there, you're going to have 2 options. You'll have 1 and 2. You'll go over to there, you'll program them to whatever station number you want to, and then you'll hit program decoder and it'll send it, and then your decoder will be programmed. You can take it out to the field and wire it up at that point. ICD-HP, you'll actually do all that out in the field. So the wireless handheld is a great feature, but it's not necessary. After I've used one the first time, I never want to go back. It was a very good thing to have. Programming can also be done on pump and master valve decoders. The pump master valve decoder is actually just an ICD 100. It's a single station, but instead of going to the top screen where you try to program it as a station, you go to the next one down and you get the option of doing a pump master valve. The pump master valve can either be done on a decoder, like we're doing right now, programming it, or you can also go ahead and just, if you're close enough, run it straight back to the controller and use one of the ports inside the controller. Either one is fine, but one little thing that you have to remember is if you do use them on a pump master valve decoder, after it's programmed, when you go to the pump master valve operation screen, you have to tell it where it's at. So you'll go to that screen, it'll ask you, where is it coming from? So as you can see in that screen there, it's on a decoder. It'll be on decoder module 1. If you have a 150 or a 225, you'll tell it it's on the wire path that's hitting the first one, the second one, or the third one. Or if it's straight back, you just choose controller. Sensor decoders, that's another option you have. You'll actually go in there and you'll program it as a sensor decoder 1 through 9 on the address, and it does not interfere with your station count or any other regular decoders. Be careful, there is polarity on those too. So especially if you're using a flow meter, make sure red to red, blue to blue on your outputs, try to keep up and make sure those are the same polarity too. I've seen a lot of them get wired up backwards. You flip the wires around and boom, you're back up and running. So it's not crucial. If it doesn't read, try it the other way. More than likely, it's just backwards. The sensors, the ICD-SEN, can be hardwired either on the sensor decoder or back to the controller. You can do 3 click type or up to 6 flow sensors. You also have to do that the same way as the pump master valve. You have to tell it where it's at, and you'll have 2 different options. You can see in the bottom screen the decoder module and which one it's hitting, 1, 2, or 3. If it's a 75, it's easy. You're only going to have that option for decoder module 1. Or if it's at the controller, you just tell it it's at the controller so it knows where to find that item. This is a very important screen that a lot of people overlook, and it's in the ACC1 and the ACC2. On the controller, you look right above the D75 module, and it'll be directly on the, and I'll show you in a future screen, on the ADM module, you have a series of lights, and those lights actually can tell you a story of what's going on if something is not right inside the controller or out in the field, something's not running. If you look, there's 4 symbols there. There's one, it's a little decoder with an exclamation. If it's blinking red, you got an overcurrent, something is wrong out in the field, more than likely it's shutting it down. On the one below it, if you try to run something, if it's blinking green, that's good sign, station's active, it's probably doing what it should be. If it's blinking red, you got a line overload. So you got a wire pass short. but it will also blink during a decoder update. We're not going to go into that right now, but just remember, blinking red is good, or blinking red is bad, green is good. The one in the upper right, the one that looks like two arrows, that's more of a communication type diagnostic tool. If it's blinking green, that means it's trying to communicate to decoders back and forth. If it's blinking amber, that means that, yeah, you've got programming port, like you were trying to stick a decoder in the two ports, and blinking amber means that you're now running it through that port for the time being. A solid amber means that you're in wire test mode. Now, the wire test mode we'll go into next week. That's how you can use your clamp on meter and go down the line and look for bad decoders, shorted decoders, problematic things that way. And then your last one in the bottom right, this is the one that seems to throw a lot of people. That one right there, it can either be blinking green or it can be solid green, or it could be off too. If it's off, you got no power, you know, it's off, something's wrong, it's getting nothing. If it's solid green, that's what you need to see. If it's solid green, that's exactly where you want to be. Everything is functioning like it should, along with no other lights. If it's blinking green, and a lot of people have called me and said, yeah, it's blinking green. Well, blinking green is actually a bad thing. If it's blinking green, the module is damaged and needs to be replaced. So remember, those four lights are actually one of the first things I go to when I go to a controller and look and see what's there. On the ACC2 decoder menu, we've already been through the program decoder, but you have other options too. View configuration, view status, station assignments, decoder diagnostics, the inventory, and update decoders. So let's take a look at a few of those. View configuration. If you look at a decoder, you can basically see exactly what that decoder is. 1 station, 2 station, 4, 6, power and inrush. Those will come factory default set. You should not have to change them, and it's not advisable unless somebody from Hunter has told you to. One of the product managers, call center, me, or one of the guys, one of the sales guys has asked me about it. Typically, that does not need to be changed, and I recommend not changing that. And it has your serial number of the decoder, your firmware version, which, you know, that could be pretty important too, because a lot of times when we come up with an enhancement or something that needs to be done, we'll come up, and I recommend updating them through the ICDHP, the handheld programmer. But here you can actually see what that version is. This one's 1.03.201. We're way past that point. If you're having issues, you can easily try to update it, and you know, it might fix your problem, might not, but it's a good start to look at something like that. And you can see this one was a 2-station decoder also, because you have the black port, station 1, to the yellow one. The 2 yellow outputs is station 2. View status. You can go and program or take a look at the status of the decoder itself by taking a look at a certain station, like this one, station 1. You can see it's normal on the status. Now, I've seen also that's a output shorted, damaged. So that's a good thing to look at. And you can also get the same diagnostics with the ICDHP at single decoders. You can see your voltage. Typically, I don't like to see that below 30, but it's going to be typically between 30 and 35. Higher, there might be an issue. Lower, there probably definitely is an issue. But keep an eye on that. A current is on this one 2 milliamps. 2 milliamps is good for one that's just sitting there dormant. Typically it's around 3, so 2 to 3 is good. Load present means that there's a solenoid hooked to it, and active is if it's on or not, and this one's not. Decoder diagnostics. If you look, this one came off of a controller that had 225 stations. So you have 3 different modules there. And that from there, you can take a look at your current. And if you remember what I just said, each decoder, when it's sitting there dormant, is about somewhere in the range of 3 milliamps. So you can take a look at that and say, okay, 40 milliamps when you first start it up, and write that number somewhere. Look at it, remember that number. Because if you come back in 2 weeks because there might be a problem and lightning storm ripped through or whatever, and suddenly you see 200 milliamps, okay, well, some of the stuff might be working, but there might be a problem or a future problem because that's way higher than it should be. And line status is good because that means it's not shorted out. It's active, it's up and running, and your module status just means that even though nothing is on, it is still running. All right, decoder diagnostics. At this point, you can go ahead and go to this screen where it says exactly which station you'd like to look at. And this is also another good screen, your decoder inventory. You can go here and pull all your decoders out in the field, and it'll look for any decoders that might be out there. And this one you can see is pulled 1, 2, 3, 4, 5, 6, 7. The communication basically tells you how good that communication is between the controller and the decoder back and forth. Is there an update available? No, not right now, because it's probably got a current version of firmware and everything looks good. So this is kind of a nice thing, because if you come back, you got some stuff not running, you can update and refresh that inventory. And if you know you're supposed to have 1 through 50 and only 1 through 30 come in, well, 31 through 50, they've been lost. They're not talking back. So we need to figure out why. Is it a bad spot in the wire? Are they damaged? It's something that it's a nice little feature to see what you have out there. And then the last screen I'm going to go to is if you have got an ACC, the first series, here is what you would look at. You got the decoder fault, modular, line activity, communication screen, and line status. So let's go through those now. It's pretty much the same as the other one. If you go, let's see, on the decoder fault, if it is blank off, that's normal. You don't want to see any light there. If it is solid red, you got a problem with the decoder output module, which is what the light is on. And you should probably replace that ADM. Blinking red means you've got a decoder that is faulted out there, or a decoder has not responded back to command saying, hey, turn me on. The one right below it, module line activity, at power up, you will see a lot of these lights blink, but it should only be for just a fraction of a second, then they'll go off. So you'll have a red at power up and then goes out. That's normal. Blinking green, it'll blink when any station that is active out there is watering. If it's blinking red, you've got an overload or a short on the wire path. So you'll have something that needs to be looked at. Solid red means you've once again got a problem with the ADM and you need to replace it. That's a pretty common one to see blinking red when you've had an ADM that's gotten struck by something. The one on the top right, that's the communication between the controller and the modules themselves. The green light, that means it'll be green when you're communicating through the 2-wire path when you tell something to turn on or any other function that you're talking to the decoders themselves. And the amber light is just like the ACC2, tells you you're using your communication port, and that's how it's talking to the decoder to do the programming. And then the bottom right, once again, green is normal. If it's blinking green, that's a bad sign. That means it's damaged and needs to be replaced. So just because it's green, that's not a good sign. If it's blinking green, that's bad. Solid green, good. No light at all, replace it because it's not getting powered and something is probably extremely damaged in there. All right, at this point, kind of take a look at some questions, and we'll go back to Reid. I'm going to give him the screen back here in a minute. So let's go back to Reid, and then we will both talk at this point. Okay, are you there, Reid?
Yep, right here. I added this picture in here.
I forgot about it.
And I just wanted to show it because I took this today, and this is on the side of my house, and some wasps had built a nest about 4 inches below where my hand was. So I just wanted to say that I risked my well-being to get this picture for you guys to enjoy. So I hope you enjoy it. But anyway, that's it. That's what we've got this week, guys. Let me pull this up here. Certainly don't expect you to write this down, but this is the correct link for next week's troubleshooting webinar. Dirk's going to go through a lot of good stuff for you guys that are out working on these systems every day. He's going to talk about, trying to find faults out in the field, using a clamp ammeter, that sort of stuff like that. So like I said, in about an hour, you'll get a follow-up email with this presentation recorded, and then it'll also have this link to this webinar next week, so you make sure you're registered for the correct one. So really appreciate you guys taking time to spend with us today.
I'm gonna stop you real quick. We had one question. Do you need to ground the HCC?
Yep.
The HCC is an easy decoder system, and it does not need to be grounded like a traditional 2-wire system. Voltage is different, how it talks is different. The grounding requirements are only whatever you have to do at the controller, but out in the field, you're fine out there. You don't have to go every 10 or 12 decoders. You're completely good on that.
Good deal. All right, thanks for catching that, Dirk.
All right, no problem.
Right. Well, good deal, guys. Yep, just saw a question come up from Gretchen. Yeah, I'll take care of that for you. So, all right, guys, enjoy the rest of your Thursday. Enjoy Friday. Enjoy the weekend, and we will see you guys next week. Thanks for joining us.
Thank you.